example. So we have two planes, P1 equal plane 1. For example, x minus y plus z minus 4 equal 0. Plane 2. For example, 2x plus y minus z plus 1 equals 0. We have two planes, and the work is here to find out the line which is an intersection of the planes. What does it mean? It means that we have two planes. I have plane 1, for example, 1, and we have the plane 2. I use here this plane 2. And their intersection, it's clear that it is straight line here. So we have here plane 2, and here we have a line, which is as a result of intersection of these planes. And we have to know the equation of the straight line. You remember the canonical view of this equation is this one. x minus x0 of the qx, y minus y0 of the qy, and z minus z0 over qz. So I use here green ink. If you know these components of the qx, qy, and qz of the vector, which is direction vector for the straight line, q vector here, and find out the coordinates of the point, I denote them like here. I don't know, these points 0, these components, these coordinates x0, y0, z0. So it means that we know the straight lines equations. The first step here, we have to know the qx, qy, and qz. The first step here, step 1. It is very easy to calculate vector q. Vector q is a perpendicular vector to the vectors n1 and vector n2. So this vector is perpendicular to the normal vectors to the straight lines. If vector n1 equal, you remember that it has ABC factors at this equation of the line or the plane here. ABC factors, they are factored beside the coordinates x, y, and z. Here we have 1, minus 1, and z. Beside the z, 1 components. We have 1, minus 1, and 1 component. And 2 has components, the factors at the second one, plane's equation, 2, 1, and minus 1. 2, 1, and minus 1. Since that vector q, because for being the perpendicular vector to both of these 2 and 1 and 2, I forget to put their bar because they are vectors, the cross products of the vectors n1 and n2. You remember that cross product we can calculate using the determinant formula. IJK, the orthogonal basis vectors for the rectangular coordinate system. 1 minus 1 as a second one row, and 2 1 minus 2 as a third one row. And we have I factor beside the vector I. Minus 1 times 2 minus 1 times 1 minus G. It has 1 times 2 minus 1 times 2, and vector K beside the vector K we have 1 times 1 minus 1 minus minus 1 times 2, and we have here A times minus 2 minus 1, it is minus 3, minus J times I bar J bar 0 and plus K. We have here 1 minus 1 is plus 2 is times 3. So vector Q has components minus 3, 0, 3. Is it perpendicular to both of them? Ага. Блять, заколебалось, что я не могу сделать, блин. Третий раз уже эту задачу перерешиваю и не могу решить без ошибок. So, let's calculate this Q vector firstly. Firstly, we have to define vector n. 1. This vector is perpendicular to the plane 1 and its components, their factors of the beside the x, y, z at the first one plane. They are 1, minus 1, 1. And for the n2, correspondingly we have the factors at the second one. Plane equations of the plane or plane's equation 2, 1, minus 1. And Q, vector Q equal the cross product. You remember that cross product gives the vector which is perpendicular to the both of the multiplied vectors, and it can be calculated through the determinant rule ijk here, the first one row, 1 minus 1 the components of this vector for first vector and 1, and components of the second vector 2, 1 minus 1 here, and we have I vector has a factor minus 1, 1, 1 minus 1, minus J has components 1, has a minor of the 1 to minor of the matrix, and plus K 1 minus 1, 2, 1 here, and we have here I times 1 minus 1, 0, minus G times minus 1 minus 2, minus 3, and K 1 plus 2, 3, and we have here 3G. I always forget to put here bar, J bar and K bar plus 3K. It means that vector Q has components 0, 3, 3. Oh, it is components, so it's better to use curve parentheses here. Okay, so this vector is a perpendicular to the n1 and either or, n1 either n1 or n2. Here you have your home assignment here. Check that. Okay, next our job, we have to find out the x0, y0 and z0. Step 2, we have to define x0, y0 and z0 coordinates of the point of any point which belongs to the line intersection, to the line intersection. What does it mean that this line is intersection and this point belongs to the intersection? It means that this point P0 belongs to the plane Y and plane, both of the plane 1 and plane 2. So if I take these coordinates and put them into the equation of the planes, they turn both of these equations into equality. So if I find out the roots of the system or the equations, and when these equations are equations of plane, I can find out this point P0 which belongs to both of them. So I have to define the roots P0 coordinates. They follows from the roots of the system of equations x minus y plus z minus 4, x minus y plus z minus 4 equal 0, and 2x plus y minus z, 2x plus y minus z plus 1 equals 0. But here we have 3 unknown variables and 2 equations. So the roots of this system we can find out only through parametrical view, because one of the unknown variable we have to turn into parameter, and it's very clear because there are infinity number of roots for this one equation and infinity numbers of points which belong to the line. So if z is a parameter, so we have to treat z as a number. We have the system of equations x minus y equal 4 minus z and 2x plus y equal minus 1 plus z. We have 2 equations and 2 unknown variables x and y, and z here is as a parameter. So we can find out the x and y through the Cramer's rules. So we have to turn this one thing into matrix form, and A equal consequently consists of the entries of A. They are factors in these 2 system of equations. They have 1, minus 1 and 2, 1. And vector B consists of the elements on the right hand side of these equations. So it is 4 minus z and minus 1 plus z. And we have here determinant of A. We have to calculate. It gives 1 minus 1, 2, 1. and gives 1 times 1 minus 1 times 2. So it is 1 plus 2, 3. Determinant A, B, 1. You remember that we have to replace the first column at the matrix A by the B matrix, and we have 4 minus z minus 1 plus z, and we have here minus 1 and 1, and it gives 4 minus z times 1, it is 4 minus z, minus 1 times minus 1 plus z, but it is minus, and we have here plus, and it is minus 1 plus z here. It gives 3, and determinant AB2 gives 1, 2, 4 minus z minus 1 plus z, and we have here minus 1 plus z minus 2 times 4 minus z, and it gives minus 8 plus 2z, and it gives 3z minus 9. So we have vector point P has coordinates x, I'm sorry, here take my time. So x1 gives, x equal determinant AB1 over determinant A, it is 3 over 3, and it is 1. Y equal 3z minus 9 over 3, and it is z minus 3. Okay, so any point which belongs to this straight line, which is intersection of the two planes, I can put it like P, has coordinates 1, z minus 3, and z. Okay. So your way to pick out z, what is your favorite number? Z can be, for example, 0. I like 0. So P for this particular situation is 1 minus 3, 0. So this point, according to our calculation, belongs to the plane P1, plane 1, and belongs to the plane 2. We can check it. If you put these numbers into the planes, we have here x minus y plus z minus 4, x minus 1 plus z minus 4 equal 0, and the second one 2x plus y minus z plus 1 minus z plus 1. We had to this plane. If I put 1 minus 3, 0 into this formula, I have 1 plus 3 plus 0 minus 4 equals 0. So it's clear that P belongs plane 1 consequently. And if I put these numbers into the second one here, my choice here, I have if you like any other number, you can put z any other number, but if z equals 0, it makes easy my calculation, facilitates my calculation. You can put, for example, pi if you like pi, or for example 100, 1,000, a billion. It's your choice. 2x plus z, I just try to check it. 2 times 1 minus 3. equals 0, don't forget here, minus 0 plus 1 and clear 0, so P belongs to the plane 2. So we find out the P point which belongs to both of these planes. So consequently P belongs to the both of the planes, and since that it belongs the line intersection. Now they are ready to make the equation of the line. We had x minus x0 over qx equal y minus y0 over qy equals z minus z0 over qz. So we have x minus x0, and the x0 it is 1, qx equal 0 equal y minus what? 3 minus 3, qy equal 3 and equal z. I had 0, so z minus 0 over q 3, and I can a little bit simplified over 3 equals z over 3. So this one calculation the equation of the line which is an intersection of the given plane. Okay, so this is the answer of this question. I can notice here dwell your attention or your head on this one fact that we have here kind of a division by 0. It doesn't mean that it is division. It means that we have here zero core components of the vector q. What does it mean, x0 components? It means that this vector belongs to the plane which is perpendicular to the axis x. So our line, the line is perpendicular to the plane, to the not plane, but it's perpendicular to the axis x, to the axis x. Since that these components is 0. Okay, so see you later, see you next time. Bye bye.